YouTube channel Data Science with Sam, and happy holidays. This blog marked the beginning of an exciting series on computer vision, a very widely popular artificial intelligence technique that's been used in different industries. So what is computer vision? Computer vision is an interdisciplinary scientific field that deals with how computers can gain high-level understanding from different images or videos. So that means we are basically making computer the ability to mimic the human visual system so it can perceive the images or videos and extract information from there. The idea of computer vision is not very different than any machine learning or deep learning models. So here also the computer extract the information from the images as a part of like a feature extraction or feature engineering process. Then it compile this information and then it train the model based on different computer vision algorithm, and then it apply the validation prediction accuracy on the computer vision system. So computer is basically processing the model based on information it's gathering and then apply that model to judge or to predict the real world phenomena. So now you might be wondering that, okay, you just mentioned that computer vision has a lot of applicabilities in different industry. So give me some example. So let's check out some of the real life applications related to computer vision in the next section. Computer vision is used by a wide variety of applications in real life world, such as object character recognition or OCR that has been used to recognize the handwritten code or letters. In oil and gas or even aircraft industry, we use computer vision to build fault tolerant system that can detect any sort of like fault beforehand. In the retail industry, we can apply computer vision algorithm to build object recognition system that can track the movement of a customer inside a store, and it will also help to perform the automated checkout. Have you heard of that Amazon Go store in Seattle? You can see those kind of stores where people can just literally walk in and walk out of the store without standing in the checkout line. So what it does actually, that computer vision system will track the movement of the customer, and every time customer picks up something from an aisle or somewhere else in the store, it will track that and it will add to their Amazon account. So without the applicability of computer vision system, it'll be difficult to set up any sort of object recognition mechanism inside the store. The next example is 3D model building. Like if you want to build a fully automated 3D model for construction purpose, in that case you can apply computer vision algorithm. Now the next thing, medical imaging. In last couple of decades, we have seen a variety of applications based on computer vision system used by the medical professional for medical diagnosis or prognosis purpose. Then the next one is the match move. So this is basically related to the CGI technology. So the full form of CGI technology is computer generated imagery technique, which has been widely used in the movie industry. If you think about Marvel movies or DC Comics movies, and think about how they actually made those action sequences possible, you can actually think about the computer vision. But what they usually do is they actually generate a computer. They actually use the computer generated sequences and add that to a real life image of an actor or actress and perform the CGI technique using computer vision to come up with the actual sequence which we actually observe in the movie scene. So without computer vision, it will be difficult to apply the CGI technique to create a real movie scene. The next one is surveillance. I mean, once you go to a store or once you go to like a bank, you'll see like there are a lot of like CCTV camera and surveillance cameras are out there. So every time you check a surveillance camera, they usually track your movement, and they also detect that where the person is moving, inside the bank or somewhere else in a highly sensitive area. So without the computer vision system, it'll be difficult to build an accurate surveillance system. The next one is biometrics or face recognition. So for face recognition, you use the similar sort of computer vision system, which will actually create points on your face, and based on the geometrical structure of your face, it can detect your face in other images. Like if you check, if you ever come across that Facebook face recognition system, you can see that if you upload an image to Facebook, and sometimes it can automatically, Facebook will suggest the name of that person, because Facebook already has an image of that person in the database. So every time you upload an image, it runs the face recognition system on that image, and if it finds any similar face, then it will try to provide suggestion of that image. So in a nutshell, so computer vision is nothing but it gives computer the ability to generate a caption from a digital image or videos. Like for example, like in the face recognition system, it generates the caption, it generates the name of a person by just running it through the algorithm and predicting the name of that face. So that's all. I mean, these are the main real-life applications that have been used by computer vision system in last couple of decades. There's so many other applications been built by in the AI industry, and you can definitely come across some of the computer vision system in future. But these are the key real-life applications that had a lot of impact in retail, manufacturing, healthcare, and other industries as well. The conceptual idea of computer vision has been around since 1960s. But due to lack of raw data, means digital images, it's been difficult to make progress in this field of study. Because it doesn't matter how robust your algorithm is, if you don't have enough data, you won't be able to train the model which can predict future phenomena in real world accurately. Back in 2006, Dr. Fei-Fei Li, a renowned professor from my alma mater, University of Illinois at Urbana-Champaign, realized this limitation of computer vision algorithms. So she started a project to build a database called ImageNet, and she started collaborating with Princeton University first to hire some undergrad students who will help her to download some images from the internet. And later on, she started a competition related to ImageNet, which also helped not only to build a better model or better computer vision algorithm, it also helped her to gather more information, more data or images which she could upload to ImageNet. By the end of 2017, when she finally concluded ImageNet challenge, her ImageNet database was comprised of more than 10 million of images. So that's huge, right? So a huge credit to Dr. Fei-Fei Li to revolutionize the computer vision world by making that enormous attempt to build a data set that would help the computer vision researcher in forthcoming years. So after this revolution in the computer vision world, what would be the next step? So you might be understanding, okay, you talk about data, but just tell me a little bit about that, how this computer vision is related to object recognition or kind of like real life application you just mentioned in the previous section. So it's very simple, like the computer vision is kind of like evolved around any sort of like object recognition mechanism. And when I'm talking about object recognition, it's actually comprised of image classification and object localization. Like whenever you see something, like whenever computer would try to detect something in an image or videos, it always try to first detect the object in that image, where the image is located inside the image or the video, and then after that it tries to classify the object based on the categories already it's been trained on. Like Tesla autonomous car, like what happened in Tesla autonomous car, we have a computer vision system which already understand the difference between a tree and a car. So every time when the Tesla autonomous car will drive on the street in our self auto-driven mode, it will always try to look for any trees or cars which can match its features, and based on that it predict that, and it will try to avoid those obstacles. So the object recognition is very important. So that's why the object recognition is not possible without performing the image classification and image localization. So I'll talk more about this object recognition in my next video, when I'll talk about one of the very famous object recognition model called YOLO, and it's called You Only Look Once. So stay tuned for that. So that's all for now. I hope you like this video. Hopefully it will give you a notion of how wide this computer vision field is, and how many different lines of applications you can use in computer vision world, and how many different type of application you can build using this AI technique. And that's all. If you have any comments or any questions related to computer vision, feel free to share your comments in the caption section. I'll be happy to answer any question, any comments related to computer vision, and there'll be more videos will be forthcoming related to this field of study, because this this field is pretty much evolving every day. There's so many research has been going on around the world. There's so many things we can talk about computer vision. So please share more information about computer vision. Ask me more questions. I'll be happy to address your question based on my knowledge on this computer vision. And happy holidays, and have a good time with your family and friends.